In this problem, we're going to show that 2 to the x equals 1 over x has one real solution. And to do this, we're going to use the intermediate value theorem. So I wrote the theorem on the right as a refresher. The first thing we're going to do is graph 2 to the x and graph 1 over x. That's going to help us. So graphing 1 over x, that's a hyperbola, right? Looks like this. And graphing 2 to the x, if you know how to graph e to the x, then you know how to graph 2 to the x. They're very similar. Right? Starts out very close to 0, and it grows very fast. Right? So it looks like we will have one real solution where these lines meet when x is positive. It doesn't look like they're going to meet when x is negative because 2 to the x will be greater than 0 and 1 over x will be less than 0. So we want to hone in on that one solution. Okay, and if 2 to the x equals 1 over x, then you can rewrite that as 2 to the x minus 1 over x equals 0, right? If they're equal, then when you subtract one from the other, you'll get 0. Okay, and we want to call this f of x. We want to analyze that. So where is f of x continuous? Well, 2 to the x is always continuous, and 1 over x is continuous everywhere but x equals 0, right? So f of x is continuous everywhere but 0. It's continuous for x not equal 0. Okay, so finding out where this function is continuous is key to use the intermediate value theorem on it. So if we want to show that this is equal to 0 and we want to use the intermediate value theorem, then we want to find some interval AB. And what we want to do is we want to have f continuous on this interval, and we want to have f of A be less than 0. And have f of B, be greater than 0. And if you think about the intermediate value theorem, if f is continuous on AB, and it takes on f of A and f of B at A and B, then it takes on every value between them at some point in the interval. So if we find some interval for this function such that f of A is less than 0 and f of B is greater than 0, then f has to take on every value between f of A and f of B, which means it would have to take on 0. And if f of x equals 0, that means that 2 to the x equals 1 over x, right? And that's exactly what we want. So we just have to pick the interval AB. And we can do this in a lot of different ways. You can get creative. So what would A be? You want to pick a point A so that f of A is less than 0. So that means that you would have to have 2 to the x be less than 1 over x, right? So what if we picked A equals 1/2? What would happen if A was 1/2? Then f of 1/2 would be 2 to the 1/2 minus 1 over 1/2. And that's the square root of 2 minus 2, right? Square root of 2 is like 1.4 something. So this is going to be less than 0. What about our point B? We want B to be such that f of B is greater than 0. So that means we want 2 to the x to be greater than 1 over x. Well, for that, we could just pick something bigger, right? This 2 to the x is going to grow. I mean, if you look at the graph, 2 to the x starts growing really fast, and 1 over x starts shrinking really fast. So if we just pick something like b equals 2, then f of 2 is going to be 2 squared minus 1/2, which is going to be greater than 0. Okay, so we have an interval AB. It's 1/2 2. And remember, f of x is continuous when x is not equal to 0. So there's no 0 in this interval, right? It's like 1/2 to 2. So that means that f is continuous on this interval. Alright, it takes on f of 1/2 and f of 2. F of 1/2 is less than 0. F of 2 is greater than 0. So it takes on every value between f of 1/2 and f of 2. So it's going to take on values that range from positive to negative. So at some point, it has to take on 0. And since it takes on 0, that means that 2 to the x minus 1 over x is equal to 0, which means that 2 to the x equals 1 over x. Now we don't need to find what value x would be for that to be true. The problem just wants us to show that there is one real solution. And that's what we've done. We used the intermediate value theorem on this interval to show that f of x, 2 to the x minus 1 over x, has to take on the value 0 at some point. Okay?